Assalamualaikum. So this is the sample data sets of purchase order. So as for the X variable, we choose item cost, quantity, AP terms, order date, and also arrival date. And also for Y, we choose cost per order. Okay. So in order to find regression statistic, ANOVA, and also etc., we have to choose data analysis, and then we click after regressions. We put the wide range, which is cost per order, and also for input X range, item cost, quantity, AP terms, order date, and also arrival dates. So if you put title of the column, you have to tick labels, and also for the output range, you can choose anywhere you want to place the data, and also after that we tick residuals and also standardized residuals. So after that you click OK and it will appear like this. Okay, for linearity, we copy cost per order and also residuals. Okay, to find the chart, first we have to go to insert column, and then we choose part line as scatter chart. Okay, we highlight the residuals and we choose the scatter chart. For you can choose any type of the scatter chart and it will appear like this. So according to the chart, the first hypothesis we can conclude is residuals randomly scattered about 0, and the second one is the residuals show no specific pattern. So we can conclude that the relationship is linear. Okay, so this is the ANOVA. The p-value for the f-test is equal to 0.0000, which we reject hash O at 5% significant level. So we can conclude that relationship is linear. Okay, as for normality, we go to the data again and we choose data analysis. Here we choose histogram and then you click OK. The input range is the residuals. You can highlight this. Okay. So for the bit range, we leave it as blank. And if you include the residuals title, you can tick at the labels. Okay, click at output range, and you can pick anywhere you want to put the data. And then you click OK. So it will appear this way. Okay, from the histogram, we can conclude that the residuals show a bell-shaped distribution, so that we can conclude it is negatively distributed. Okay, to find homoscedasticity, we can do the same thing like when we want to search for the linearity. Okay, as for the autocorrelations, first we this is the formula, and then first thing first, if you want to find the ET, you have to copy the data from residuals. Then we paste. Okay, the second one is paste it here. Okay, to find this one, we have to sum. Stupid. And then enter. Go and then you drag until the end. Okay. And then to find this numerator, what to do? Then you drag again until the end. Okay, to find this one, you have to click here, then square it. Okay, again drag until the end. Okay, and then you find the sum for the numerator. Then click enter. Same goes to the denominator. Then click. Okay, to find the Darwin Watson is you have to divide this one divide with this one, so you'll get 2.10009. So the acceptable range 1.5 to 2.5. Since the Darwin-Watson value is 2.1009 within the acceptable range, then we can conclude that there is no autocorrelations.
For multicollinearity, copy the data which is from item cost until data cost per order, and then click data analysis, click coloration, and then click OK. For input range, put the item cost until they are variable, and then click label in the first row, and then for output range, you can choose whether you want to place the data. Click OK. Then the data will appear like this. For summary output, you can click the data analysis. You choose regression. Click OK. And then for input Y range, you can choose cost per order until for input at range, you can choose item cost until the arrival date, and then you click the label, and then for the output range, you can choose anywhere you want to place the data, and then you click OK. The data will appear like this. And then for another summary output, you can copy all of this and paste it under here, but you need to delete the arrival data. This you need to delete it. Okay, then you clear all of this which the delete or clear contents. For clear contents, and then you click data analysis. You click regression again, and then click OK. For input Y, you choose the cost per order, but for input X, you just take item cost until order data only, order date only, and then you click label. For output range, you can choose anywhere you want to place. Then you click OK. Then the data will appear like this. Okay, for the final mode, copy from, you can copy from multi-collinearity. Okay, this for model explanation. Number 1, how good our R square, which is 49 of Y, can be explained. 49% of sale can be explained by advertising expenditure and selling price. For p-value, for intercept, which is 0.9485. For item cost, 2.2194. For quantity, 4.33725E. For AP turns months, 0.047912. For order date, 0.951036, which is relationship between X and Y. HO, there is no significant relationship between X and Y. H1, there is significant relationship between X and Y. For HO, there is no significant relationship between item cost and cost per order. Since p-value equal to 2.21 more than 0.5, we can say that we have failed to reject HO at 5% significant level. Another HO, there is no significant relationship between order date and cost per order. Since p-value equal to 0.951 less than 0.05, we can say that we will reject HO at 5% significant value. So we can conclude that order date has no significant relationship with cost per order. This is the coefficients. For AP months is more influenced because highest beta value, which is Y. For the Y, we can say 290033.402. Okay, that's all from us. Thank you.